right. Any questions over the homework before we start? What we're doing today is talking about applying transformations to a function. The main two we'll be looking at today is horizontal translation and vertical translation. Now, you don't need to write all of this. The main thing we need, especially since horizontal translation, the general form is f of x minus h. So when we talk about applying a horizontal translation, moving the function left or right, we're doing a translation of f of x minus h. The other one we have is a vertical translation, which is going to be our f of x plus k. Horizontal is our left, right. Vertical is our up, down. So what we're going to be doing is actually applying these transformations. Now, one thing we do need to get down is the function itself, f of x, and we're going to be translating or doing a translation of 3 units down. So you can do a, and then we can write f of x equals 2x plus 1, and we're doing a translation 3 units down. And we're going to call the new function g of x. Now, when we do a translation up and down, we're going to use the general form for a vertical translation. And the general form for vertical translation is our f of x plus k, where k is the amount that we move the function up or down. And for this here, the value of k in this case would be 3, because we're moving it down 3. Now, would that be positive 3 or negative 3? Because positive is going to be up, negative is going to be down. So it would be minus 3, negative 3. So we replace k with its value because we're moving it down 3. Now, we also need to replace f of x, because we have f of x here, with what it is equal to. So we replace f of x with 2x plus 1. Questions on this so far? Now, the last thing we need to do here is simplify our expression. Is there anything in front of the parentheses for our 2x plus 1? No, so there's nothing we need to multiply through, nothing we need to distribute, so it's still going to be 2x plus 1. Now, the next part, we can write plus negative 3, but we're not normally write plus negative. We just write negative 3 minus 3. Because plus negative 3 is the same as just saying minus 3. We'll just write minus 3. Now, we can say we're done. This is the final equation as long as there are no like terms. Well, 1 minus 3 does combine, yes? 1 minus 3 is negative 2. So our new function, after we translated it 3 units down, is 2x minus 2. Questions on this here? Up and down movement is nice. Let's look at the next one. Now, f of x, we're still using the same function. f of x is equal to 2x plus 1. However, this time, we're doing a translation of 2 units to the left 2. And this time, they also want to call it h of x. Now, the general form for translation, moving the graph left or right, is f of x minus h. I will also say at this point, f of x, h of x, these letters are just a way to name them. So there is no specific order to which we name them. I'm not going to be particular about how you name them. We just need to be able to name them so that if we're referring to them, we know which function we're talking about. How far are we moving to the left or to the right? 2 units. So we know h is going to have to be 2. Now, since we're moving 2 units to the left, would it be positive 2 or negative 2? Because left is normally what? Negative, yes? So h is indeed negative 2. But now we have the question of it's always the opposite of what we think, yes? Well, let's look at what we have here. We have x minus negative 2. Do we leave a minus and a negative next to each other? Well, no. So what we actually have here is what? F of x plus 2. So we do have that opposite. It's just we fill it in as that minus negative and the negative negative make a positive. If it had been right 2, we would have plugged it in as positive 2, which would have left us with x minus 2. So we still have that opposite. It's just we have to plug in what the actual value is. So we kind of see how this works with h. Even though, again, opposite of what we think, because h is negative 2, but now it looks positive. Questions on how we did that there? Questions on any of this so far? Now, as we go to the next step, what we have is f of x plus 2. The original function told to us is f of x is 2x plus 1. Do I still have f of x? Not really. We have what? F of x plus 2, yes? We've replaced this x with this x plus 2. So that means this x up plus here, this x here has to also be replaced with this. So the 2 is still the same, but instead of x, we have x plus 2 plus 1. And we've done stuff like this before. We've just not, or y'all have not done it with necessarily expressions. Because if I told you to find f of 3, function notation, you don't have to write this. We would have said what? 2 times 3 plus 1, because we're evaluating it when x is 3. We're plugging x for the value of 3 in for x, and then simplifying from there, yes? Did we ever say that it had to be just numbers? No, it can be any expression that we want. However, up to this point, y'all have only really done numbers. We've not done an expression like x plus 2. It's just for us a way to say we are putting this into the function. Questions on this so far? We need to simplify this, and we can distribute pretty nicely. 2 times x is 2x. 2 times positive 2 is plus 4 plus 1. Combine our like terms, giving us 2x plus 5. Now, I would say definitely jumping from f of x equals 2x plus 1 to try to go straight to 2x plus 5, that's a bit of a jump. But if we take it step by step, part by part, using the general form, plugging in our information and simplifying down, there's not a whole lot to this from step to step. That's going to be algebra 2 in a whole. It's going to be a lot of nice steps as long as we keep them in the order. They flow from one to the next. Questions on how we move this left 2? We moved it left 2 or up 4. It's a similar movement. But that's mainly with linears. Linears are a little weird that way. We'll get to another left right here in a minute. Actually, we probably have time. This is, I think, where we stopped, yes? Or we had to go take a phone call? Okay. Let's look at some more. Let f of x equal 4x minus 9. So we'll need it. And we want to translate it 5 units up. So we'll need f of x 5 units up. And they want us to call the new function g of x. Especially on the homework tests, whatnot, if you call it g of x for this one here, or you call it h of x, m of x, n of x, I'm not too worried about the name. More looking at the equation. General form for vertical translation. Is f of x plus k. That's moving it up and down. Interestingly enough, the f of x part, we can make it whatever we want. All we're saying is we're taking the function f of x and we're moving it up or down by this amount. We're moving it up or down by the value of k. That's all that's saying. So that means if we wanted to apply it to, say, g of x, we would not say f of x plus k. We would say g of x plus k. It's just the name of the function. What function are we applying it to? And for us here, since we're moving 5 units up, that means our value of k is going to be 5. Would it be positive 5 or negative 5? Because if we're going up, up is positive, so it's going to be positive 5. So we're good there. Here we still have just f of x. We don't have f of x plus 2. We don't have anything inside those parentheses besides x, yes? So technically what I'm doing is I'm replacing this x with x, which doesn't do anything. It just gives us that function back. Now again, I always make sure, especially you'll see as I write these here, a lot of the times, like this here, we don't need the parentheses. However, it's better to put the parentheses and not need them than need them and not put them. Since there's nothing in front of the parentheses, we will still have just 4x minus 9 plus 5. We do have like terms. Negative 9 plus 5 is negative 4. If we'd have moved this function up 9, we would have had negative 9 plus 9. What is negative 9 plus 9? 0, so we just have 4x. There's nothing that says that we can't just have that constant term, that number just cancel out or simplify out. Questions on this here? No? We'll still need the function f of x. F of x equals 4x minus 9. And it'd be good to note that we're translating it 1 unit to the right. And again, they wanted us to call it h of x. Now our left-right translation is f of x minus h, where h is our movement to the left or to the right. And it says we're moving how far? 1 unit, yes? So we'll put 1. Will this one be positive or negative, the one we're plugging in? Because we're moving right, yes? Right is positive. So we're plugging in positive 1, which gives us x minus 1. That's why, again, we get that opposite of what we think. We did plug positive 1 because we did go right 1, but now it looks like it's negative. It's that flip. Questions on this here before we do the next step? So, as we can see here, we don't have f of x anymore. We have f of x minus 1, which means I need to go to the original problem and replace this x with x minus 1. Telling us we have 4 times x minus 1 minus 9. So really the only thing we're doing is just replacing the x with x minus 1. And it really doesn't matter what the function is. I would not write this down, because we could have something like and if we did the same thing with x minus 1, it would just be 4 times x minus 1 squared we just replace the x with that value. The other piece is connected to it, the squares, absolute values, other stuff around it's not going to change. It's just going to be that value. Questions on how we got to 4 times x minus 1 minus 9? Distribute 4 times x is 4x. 4 times negative 1 would be negative 4 minus 9. Negative 4 minus 9. Negative 13. I think y'all were the group that was a part of the Common Core, the core math, doing all those addition, subtraction and stuff. Because if some of this, one of the ways to think of this as you're adding up, because we're really adding 9 and 4, yes? How far away is 9 from 10? 1. So if I take one of those out of 4, I'm left with 3. 10 plus 3 is? You can do that with any number. Either direction, 8 is 2 away. So we're left with 5 with our 7, 15. It's just ways to manipulate the numbers to get what you want. Yep. When I calculate y'all's grades, that's the same thing I do, especially on tests. And this is a side note, because if I know that you missed, I'm just going to say 28.5 and it's out of 100. I always start with 0.5, because 0.5 will get me to the next whole number, which is 29. 1 will turn 29 into 30. 7 would get me to 100. So instead of having to do 100 minus 28.5, went the opposite direction, still get to the same answer. Let's look at these next two. This next one's actually kind of nice. It's actually really nice. F of x equals 3x. We want to translate it up 5. They didn't tell us what to call it. One of y'all give me a letter. Doesn't matter what letter. Hey. We'll call this new function a of x. Now the general translation for up and down is our f of x plus k, where k is the amount we move the function up or down. Our k amount for this is 5, and it would be positive because we're going up, yes? Nice thing is we still just have f of x, so we can replace it with its function 3x, because f of x is 3x. Is there anything in front of our 3x? Nope, so it's just going to be 3x plus 5. No like terms, nothing we can do. It's just 3x plus 5. Questions on this here? This one's kind of nice. We literally just added 5 to it and we're done. F of x equals the absolute value of x minus 3. We're going to translate it 4 units to the right. We can use the same letter, a of x. General form for translation left is right is our x minus h. What would the value of h be? So we know the number value is what? 4, yes? H, since we're moving right, is going to be positive 4, so we would plug in positive 4. But by doing that, it makes it look negative, so we get that x minus 4. Questions on this here? Now we just need to plug this back in. Since we have f of x minus 4, it means this x inside the absolute value bars needs to be replaced with x minus 4. Every other part of the function stays the same. We still have the absolute value bars. We still have the minus 3. If there was a number in front of the x, we would still have it. But this is what we have. Is there a number between that absolute value bars and the parenthesis here? No number, no sign, so nothing to distribute, which tells us we have the absolute value of x minus 4 minus 3. And interestingly enough, that's as far as we can take it, because I cannot take that negative 4 out of the absolute value, and I cannot stick the negative 3 or the minus 3 inside. That as far as it goes. Are you ready for the next piece? Reflections. A lot of information here. We don't need all of it. Reflection across the x-axis. General form, negative f of x. Reflection across the y-axis, f of negative x. So if we're going across the x-axis, it's negative f of x. If we're going across the y-axis, it's negative f of x. So let's see what this means. So let f of x equal absolute value of x plus 3 plus 1. So we'll need this. And we want to write a function g whose reflection in the x-axis, reflection across the x-axis. Now, the general form for a reflection across the x-axis is negative f of x. And when we apply this to it, we have the negative, and we just have the function f of x. So the f of x part is still going to be the absolute value of x plus 3 plus 1. That doesn't change. We just have this negative in front of the whole thing. Which for us means we're now going to have to distribute that negative through. So we're going to have to multiply the negative by the absolute value and the 1. And we multiply a negative by an absolute value. We multiply a number times an absolute value quantity. We put it in front. It just hangs out front. However, when we multiply that negative by positive 1, it's going to become negative 1. And that's it. So when we reflect the function f of x across the axis, or the x-axis, we get negative absolute value of x plus 3 minus 1. Questions on this here? We'll stop here. We will finish this